You ever just stop and think about what's actually going on behind the scenes of an app you use every day? Well, today, we're going to do just that. We're pulling back the curtain on Bumble, and you're going to see the incredible tech that makes a simple swipe, well, not so simple. Yeah, really think about that. 150 milliseconds. That's faster than a blink of an eye. And in that tiny slice of time, a whole cascade of events kicks off. So in this explainer, we're going on a little adventure. We're going to follow that one single swipe and see exactly where it goes, from your screen all the way to a potential match. Okay, so this slide is super important because it gets right to the heart of why Bumble is such a unique engineering puzzle. Think about older, more traditional apps. You'd go in, search for profiles, and browse. That's what we call a read-heavy system. You're mostly just reading data. But Bumble, it's all about the swipe, swipe, swipe. Every single one of those is a new action, a new piece of data that the system has to write down instantly. This makes it a write-heavy system. And trust me, that one difference, it changes absolutely everything. So let's start at the beginning. Before you can even think about swiping, Bumble has a really important job to do. It has to figure out who to show you in the first place. This is all about building your feed. Right. That stack of profiles you're scrolling through, it's anything but random. There's a whole dedicated discovery service working behind the scenes, basically pre-building these lists of potential people for you. And it's looking at all the key stuff. Your location, obviously, your age and other filters, how active other users are, and yeah, even whether someone's using a premium boost. It's all about curating that list to give you the best possible shot at a match before you even lift a finger. Okay, so you found a profile you like, you make the move, you swipe right, and now the race begins. Let's follow that swipe as it dives deep into the brains of Bumble's system. And this is the massive challenge for Bumble's engineers. We're not talking about a few swipes here and there. At peak times, the system is getting slammed with millions of swipes per second. And every single one is a new piece of data, a write, that has to be captured perfectly with zero delay. So what do? I mean, seriously, what kind of system can possibly handle that constant flood of information without just falling over? You know for sure that a normal, old-school database just isn't going to cut it. It would be way too slow. You need a totally different kind of tool for this job. And that special tool is called a NoSQL database. A great example is Cassandra, which is what they use. The best way to think about it is like a giant never-ending notebook. You can just keep adding new entries to the end super fast without ever having to go back and reorganize the whole thing. It's built for one thing, speed. And it can spread its work across tons of computers, which makes it absolutely perfect for Bumble's crazy write-heavy demand. Okay, so here's the play-by-play of that journey. Step 1, you swipe right on your phone. Bam. Step 2, that swipe hits Bumble's front door, something called the API gateway. Step 3, it's immediately passed to the swipe service, which, you guessed it, writes it down in that crazy fast Cassandra database. And then, step 4 is cool. Your swipe basically gets announced to the entire system on what's called an event bus. It's like shouting, "Hey everyone, a swipe just happened," so all the other services know what's up. All right, so your swipe is safely recorded, but the mission's not over yet, not by a long shot. Now comes the moment of truth, the part we're all waiting for. Did they swipe right on you too? Now, trying to search that enormous Cassandra database for one specific swipe would take forever. It'd be like looking for a needle in a continent-sized haystack. So the system does something really clever. It first checks a much smaller, lightning-fast cache called Redis. You can think of Redis as the system's short-term memory. It only keeps track of the most recent swipes, making it incredibly fast to search. And because of that clever trick, we get this, O1. Now, that's the techie term for what's called constant time. But what it really means for you and me is it's instant. It doesn't matter if there are 1,000 users or 100 million users online. The time it takes to find a match is always the same, practically zero. It's instant match detection. Boom! It's a match. The system finds that mutual like, the match service officially creates the connection, the chat window opens up, and that little notification you've been waiting for gets zapped to both of your phones. And remember, all of that happened in way less time than it took me to say this sentence. But the tech's job isn't over yet, because now, one of Bumble's most famous features kicks in, the 24-hour rule. The system itself has to enforce this, and it uses that same Redis cache we just talked about. When a match is made, it sets a time to live, or a TTL, on it. It's literally a 24-hour countdown timer that starts ticking the second you match. So we followed one little swipe from beginning to end. Pretty cool, right? But now let's zoom out a bit. How does Bumble manage millions of these journeys all happening at the same time while keeping everything running smoothly and, just as importantly, safely? Well, one way is by using machine learning to constantly improve your feed. These complex models are always running in the background, crunching the numbers. They create a recommendation score for every person you could potentially see, weighing all these different factors to try and show you the absolute best people for you, right at the top of your stack. And safety is just as critical as speed. The whole system is designed with this in mind. We're talking machine learning that can automatically spot inappropriate content, photo verification to make sure people are who they say they are, and other systems that block spammers and quietly boot out anyone who breaks the rules. It's all built right in. Of course, things can and do go wrong. A great system isn't one that never fails. It's one that knows how to fail. And Bumble has a backup plan for pretty much everything. If that super fast Redis cache goes down, no problem. It'll just check the main database instead. It might be a little slower, but it still works. If the fancy ML system is unavailable, it just switches to a more basic rule-based feed. The point is, your experience keeps going uninterrupted. You know, this quote from the source material just wraps it all up perfectly. Bumble is, at its core, a write-heavy, real-time matching system optimized for swipe speed and low latency. Every single decision we've talked about comes back to that, being fast, handling a ton of new data, and making sure the rules that define the Bumble experience are enforced by the code itself. So it kind of makes you think, doesn't it? Every single tap, every scroll, every little swipe you make on your phone, it's just the tiny, visible tip of a massive engineering iceberg. So the next time you're using any of your favorite apps, take a second and wonder. Think about the invisible dance of databases, services, and caches happening in the background, all in milliseconds, just to make it all feel so simple. What unseen engineering is powering your world?